Hello guys, welcome back to the channel. I'm recording this video real quick before figuring out what to eat for dinner tonight. So, shorthand and longhand notation for galvanic cells. These are not that bad, as in, well, we already know half of it if you watch the previous videos, because the longhand notation is basically just these, like this, then this, and that's the longhand notation. So basically, like like you would assume it would be just longhand, the long form. And shorthand notation is it's basically telling you about the long. I mean, the shorthand notation is telling you about the longhand notation, but in a short form. So let's take this for example. I use this one up here. I transferred the longhand notation over here to make it easier. So I'm going to write the shorthand notation for this exactly and show you how it's done. So there are different ways of starting, but they all end up looking pretty similar. But for this, I'm going to show you you can start in the middle. So in the middle of it, you know how there's a salt bridge in the middle of the longhand notation? In the middle of the shorthand notation, you're supposed to draw a bridge, a little bridge, to identify the salt bridge. And on the other side of the bridge, so it starts with you write the stuff that's on the bridge. It looks like something like this. This is how a shorthand notation would look with the chemical reagents in here. So like the things that are being reacted in galvanic cells, they go in here. I'm gonna write them out. So for this one, it is zinc. I'm gonna write out the equation for the longhand as well. So it's zinc solid zinc is getting oxidized at the anode, equals to zinc 2 plus 2e, and then at the cathode it is Cu 2 plus is getting reduced to just copper. And what that would look like in the shorthand is just the aqueous solutions would be on both sides. So the stuff that is in the solutions basically 2 plus, and you're supposed to add the aqueous part. You're supposed to add the states in, and then this part as well, Cu2 plus aqueous as well. And as you can see, the anode on the left and the cathode on the left still remain. The anode's on the left and the cathode is on the right side of the salt bridge. And then on the other side, you write the solid. So it goes aqueous, gas, solid. Let me write that. Let me label it. It goes on this side, aqueous, then gas, and then solid. But for this reaction, we don't have any gas, so we go straight from aqueous to solid. And on this side, we write the solid part that's reacting, the zinc solid on the outside. And then for this part, the solid, that's and then cathode, is copper solid. And now I'm going to do another shorthand notation to help you understand it more of the second reaction. This one where we have two ions. So you may be wondering, if we have two ions with no solid, what do? We do something similar here where the left hand looks the same since it's still zinc, aqueous to solid. Still going to look like this. And now on this side, we have two aqueous solutions. So we have Fe 2 plus and then Fe 3 plus. So we write them both out like that with the aqueous. And then on the outside, we don't have a Fe solid, but we do have a platinum. Remember the inert electrode, the electrode that's in place so it can bounce, the electrons can bounce off and reduce the Fe3 to Fe2 plus. We add that in the shorthand as well. So it becomes like this. And this is the shorthand notation for the other. You could also add this part, I guess, if that matters. This is the shorthand notation for this longhand notation. And another thing that you could see in some notations, but not particularly this one, is if you're given the molarity of the aqueous solutions, you can include that. So let's say if zinc 2 plus has a 0.1 molarity, you can add that in brackets in the shorthand. And then Fe, if they have different molarities, you can add This one has 1.0 molar, while Fe3 plus has like 0.1 molar. You can add it like that. And then let's say this has a gas phase, even though zinc doesn't, just to make that clear, but if it had a gas phase and if it had a gas and an aqueous phase in here, you could add both the gas and the aqueous. So obviously you put aqueous for here, then the gas, and then the solid. And that's how the shorthand notation goes.